Let's look at the first question. It's integration of cosine power 6x times sine cube x. Whenever we have an integral where sine has odd power, the method is which works is you can peel off one sine. Okay. Now the cosine actually is fine, but sine square x, the remaining sine square x can be replaced in cosine format. And we have sine x dx. Now, if we make the substitution u is equal to cosine x, du would be negative sine x dx. And we see that sine x dx is already in the question. Sine x dx is equal to negative du. So let's try to make the substitution. Cosine x is u, so u the power 6, 1 minus u square. And this part can be replaced by du with the negative sign. Negative sign I write outside. You can multiply this inside. So what do we have? Minus u the power 6, u the power 8 du. The integral of u the power 6 is u7 by 7 minus u9 by 9 plus c. That is negative u power 7. U power 7 is cosine power 7x by 7 plus u power 9. So that is cosine 9x by 9 plus c. This is your answer to the integral. Let's work on part B. If we have an even power of trigonometric function like cosine actually, we remember from our trig, cosine square theta is 1 plus cosine 2 theta by 2. So this can be converted to cosine square theta is 1 plus cosine double of whatever is angle, double 2t. So the angle here will be 4t divided by t with respect to t. Integral half can just pull out 1 plus cosine 4t dt. Half is just here. Integral of 1 is t actually. The variable is t. Plus integral of cosine is sine 4t by 4 from 0 to pi. So let's put the limits. Upper limit minus the lower limit. When I put upper limit, pi plus sine 4 pi by 4. When I put 0, this is 0 plus sine 0 by 4. Sine 4 pi is 0, sine 0 is 0, all these terms are 0, so we only are left with pi and half is outside. The answer is pi by 2. Here we have a question, both sine and cosine are even powered, so peeling one will not really work. So I'm going to convert sine square, use sine square theta is 1 minus cosine 2 theta by 2. And cosine square theta is 1 plus cosine 2 theta by 2. So using that, sine square is 1 minus cosine 2x by 2. Cosine square x is 1 plus cosine 2x by 2. Integral with respect to x. 2 times 2 is 4, 1 by 4 outside. Now this looks like a minus b times a plus b. A minus b times a plus b is a square minus b square. So that should be 1 minus cosine square 2x by, by before we took it out, dx. Now 1 is easy to integrate, but for cosine square we need to use the formula one more time. Integral 1 minus cosine square is 1 plus cosine double of what angle? So that will become 4x now by 2 dx. 1 by 4, 1 minus half minus cosine 4x by 2 with respect to x. You see 1 minus half is just half. And now I can integrate everything. 1 by 4. Integral of half is x by 2 minus half integral of cosine is sine 4x by 4 plus c. So x by 8 minus sine 4x by 2 times 4, 8 times 4 is 32 plus c. Let's look at this last part. This is tangent x times secant cube x. Secant cube x is a odd power, so I'm gonna peel 1 secant x and keep secant square x here. Now I'm gonna use this substitution. U is secant x. When I differentiate derivative of secant x times tangent x with respect to x, you see that which I peel together with dx can be replaced by du now, and secant square x will become u square. This is a very easy integral now. U cube by 3 plus c. U have to be replaced back by secant x, secant cube x by 3 plus c.